Alright, so I'm back with, I guess, episode 2 of this, Leetcode training arc, I would say. It's not really much of a series or, a tutorial. It's kind of just, a personal sort of training thing. But, yeah, so last episode, last night, um, I kind of failed this problem, longest substring without repeating characters. But that was also the first sliding window problem I tried. So today, I'm going to be trying to do the next one, which is minimum size subarray sum. So I have it opened up here. Um, I haven't really looked at the problem yet. Um, I will just read through it now, I guess. Um, okay, so given an array of positive integers num and a positive integer target, return the minimal length of a subarray whose sum is greater than or equal to target. If there is no such subarray, return 0 instead. Okay, so let's look at some test cases. Like I said, target is 7, and nums is this array here. So I guess you kind of just have to find a little contiguous portion of this array that sums to the target. So in this case, I guess 4, 3 is the most optimal one. Okay, and here the target is 4. Okay, so that makes sense. We just need a length of 1. And here our target is 11, and it's not actually attainable, so our output is 0. Okay, and the constraints are that our target is less than that value. The length of our array, it's at least 1. So that's interesting. So we can't get an empty array. And then all of the elements are less than 10 to the 4th. Okay. So I think what we need to do, like last time, actually, yeah, I read this last video, the whole screen sizing was wrong. Like half the screen was cut off on the sides. Also, my face cam wasn't there. So I think I have that all fixed now. But yeah, last video I was showing my notebook on the face cam, and I just didn't show because the face cam wasn't there. But hopefully now I have that fixed. So yeah, I'm gonna write out. I'm just gonna try to go through this first test case and try to understand how the sliding window approaches here. So we have 2, 3, 1, 2, 4, 3. And so as always, we start. We have a left pointer and a right pointer. And what I think we need to do is kind of keep track of a running sum through the array. So I think it might be called a prefix sum. I'm not totally sure how that works, but I think so. We start L and R at 2, right? And I guess our initial sum will just be the first element, so 2, right? So that's less than the target. So what we need to do is we'll keep our sum as 2, and then we'll move R to the next value, which is 3. And then we'll add that to our sum. So now we have 5. That's still less than the target, so we'll move R to the right again. And now we have 6. That's still less than the target, so let's move it to the right again. And now we are at 8. So at this point, our running sum is greater than the target. So what we need to do is we need to start popping values off the back. So this is when we start incrementing the left pointer. So we move left from the 2 to the 3, and then we subtract the value that we popped off from our total. So our total was at 8 before. Since we just shifted L from 2 to 3, we can pop off that 2, so essentially subtract it. So now our total goes back to 6. But 6 is less than our target, right? So now we need to increment r to 4. So it goes from 2 to 4. Now our total is 10. And let me just make sure these add up, right? So if I go 3 plus 1 plus 2 plus 4, that should equal to 10. 3 plus 1 is 4, 4 plus 2 is 6, 6 plus 4 is 10. Yeah, so that makes sense. Okay, yeah, so now 10 is too big, so we need to increment left, and we'll pop the 3, and then we get to a 1. Okay, so now, once we pop that 3 off the 10, we get to 7. And that is our target. So we should store that as, so our minimum, I'll just call it minimum, and that should be equal to right minus left plus 1. And before we update minimum, so I think we, so minimum will initialize to 0, right? And then if we find a match, we set minimum equal to that first match. But for all subsequent matches, we need to check if the match is smaller than minimum, because we want to return the smallest length subarray, right? So our minimum here is set to right minus left plus 1, so that should give us 3 in this case. And now, once we hit a match, what should we do? Should we increase L or increase R? I think we should increase L. Okay, so if we have a match, increment L. Because I'll show this to the camera. I don't know if this is very visible. But yeah, basically, if we have a match here, right? 1, 2, 4, that's our subarray. We don't want to increment right because we know that incrementing right will just give us the wrong answer. We know it won't give us a valid subarray, right? And if we increment L, then that's basically just skipping a step, because if we increment R first, like we move R to 3, then we're going to have to move L anyways because we've overshot our target, so we need to pop off the end. So there's no need to move R first because we're going to end up moving L anyways at the end. So what we should do is just move L first. So we move L to 2, and now we pop that 1 off, so we go back to 6. And that's too little, so we increment R, and R goes to 3. So now our total becomes 9. That's too big. We've overshot. So now we increment L to 4. And then pop off that 2. That gives us 7. Now we do right minus left plus 1. So in our case, that's index 5 minus index 4 plus 1. So 5 minus 4 plus 1 is 2. We check that against our minimum. It is less than the minimum that we previously found of 3. So we update it to 2. And now that we found a match, we would increment L. And at this point, L has caught up to R. We pop that 4 off the end. We're back at 3. We've undershot, so we need to increment R. And now R is greater than the size of the array, so we end. So I think that makes sense. I think I've kind of understood like the whole like strategy here. So why don't I go and try to code it up, right? So we'll start our return value at 0. So in the case that we don't find any subarray, we have to return 0. So we'll just keep that there. And we'll start left equal to 0 as well. And now what we need to do is keep a track of our running total. So total is equal to, okay, yeah, so this makes sense, right? This total is analogous to the visited char set from last problem. So we need to initialize total to be equal to just the first element in the list. So I guess nums at index left. I could also just put num0, but I think this has better clarity if we set it as a left pointer. So now, for right in range lang nums, so we basically run until right goes past the rightmost bound of the array. And so what we need to do, so we're going to check first. So if total is equal to target, then I do if target okay, yeah, so we need to check if our return value is equal to 0 first. So this is the case of the first match. So we'll do rtn is equal to right minus left plus 1. Else, if we have found a different match, do rtn is equal to min rtn comma right minus left plus 1. Now that makes sense, right? Because if we just only had this line, it wouldn't actually initialize, it wouldn't update rtn at any point, because we started it at 0 and no match will ever be stolen at 0, right? So that's what we do, right? Okay, so if there isn't a match, oh, okay, and if we do this, we also need to increment left by 1. So total is equal to total minus nums left, because we need to pop off the back, and then we'll increment the left pointer by a little bit. Yeah. Else, if we don't have a match, there's two cases. Total is too small, so we need to check if total is less than target. So then we need to increment R to add more values. So we do right plus equals 1, total plus equals nums right. Else, if total is greater than target, then we need to increment left, right? So we do left plus equals 1. And I think we can kind of just reuse that code, right? That's the same thing as popping off the left. And then the end, we just return RTN. And I think the reason this works, the reason we can kind of just increment the left here is because we're guaranteed that there's no negative values. If in the array we had a negative value, and our left pointer was on it, right? Okay, well this wouldn't work with negative values because if the total is too small, I think incrementing r could cause the total to become actually smaller. So I don't actually know if you would approach it with negative values. I think that's a harder problem. That's something else, but add comments. So total is too large, pop off the left. And I think I have a feeling that might be it. So I mean, let's run it. Oh, list index out of range. Okay. Um, shit, I realized I don't think we need this else statement here. Oh, we have made a mistake here, I think. This needs to be 0. Wait. I think I realized a problem I might have overlooked. So in our implementation, right, what if the first value itself is just greater than the target? So here our target is 7, right? And our first value is like an 8. Then, I mean, L and R are both on that 8. We shouldn't, I mean, we can't pop anything from the left at that point, right? At that point, we just have to move past it. So we would have to just increment L, but then L would be greater than R. So, I mean, how do you handle that? Right? I don't know if that makes sense, but Yeah, so that's kind of weird, right? Oh, well, that should be. Wait, I'm so confused. What did I do? I know this won't work. Yeah, okay. I accidentally just indented it too much. Oh, okay. This is the problem here. Um, I think I need to put this in a while loop because we need to do. Okay, wait, hold on. If I'm doing this correctly, oops. So while total is greater than target. Okay, so I think that would work in this case. Let me just see. If I just had like a bunch of 8s in a row, right? So we had 8, 8, 1. Then L and R both start here. The total is too great, so it's not in stop left. F is equals 1, and now the total. So R moves here. Then we check it again. Oh, okay, wait. I think this should work, if I'm not mistaken. The only thing I need to do now is I'm not sure if this logic is actually correct. So I'm going to go through it with the 231, 243 code. 231, 243. This test case. I don't know why I said code. Okay, so L and R both start here. Total plus equals so total equals 2. Total is not greater than the target. Total is not equal to the target. So we just increment right. R total is equal to 5. R goes there. Total is equal to 6. R goes here. Total is equal to 8. While total is less than target, we move L and pop off nums.left. So now we're back at 6. So we increment R. Now we're at 10. 9. Still too big. 7. Okay. So now, what did I just do? 3, 2, 5, 6, 8, 6, It's supposed to be 7. Because okay, so now if total is equal to target, which it is, okay, yeah, so set RTN is now equal to 3. And then well, I don't think we need this step here. I'll tell you why, because we're already doing it here. So the next iteration, this will already run. So I'm fairly certain we don't actually need this. If I'm doing this correctly. Right? Okay, wait. Okay, so those ones passed. Right, this happened to me last night. These ones passed. Okay. Why did this one fail? Why is our output 0? So if our output is 0, that means we're not even finding a match, right? So let me write this down. I'll try to do this. 1, 2, 3, 4, 5. And we start L and R at 1, where total is here. Okay, so increment R. So 1, 3. Right, our target is 11. Okay, so now our thing is 15. Now, we've reached the end, right? So now left should start popping. 14, go, 12, L. Wait, I'm so confused. Wait, what is actually the... Why is it... 3? Wait, like, I'm not even... Did I just read the problem wrong? Contiguous, not empty C. Right. So I'm confused. Like, where is the subarray of 11? Because, I mean, this is 12. Right? Like, 1, 2, 3, 4. That's... I mean, that's 10, right? And what is 2, 3, 5? Oh, yeah, that's 14. I'm so confused. What did I do wrong? Why is this test case? Why did it expect 3? I'm so stupid. Oh my god. It's whose sum is greater than or equal to target. Oh, I just read the problem wrong. It's not equal. It's greater than or equal to it. Bruh. Okay. So how do I change this code now? What do I even do? Okay, well, that should be greater than or equal to, right? Now, if the total is greater than the target. No, it's not too large. It's large enough. Pop off the left. I feel like so stupid right now. I just like did not read the problem correctly. Okay. Let's see if this will work. Well, the total is greater than the target. Yeah, I have a feeling this will work. Okay, well, it passed these ones. I mean, we all know how that goes. Will it work? Okay, wait. That's actually a pretty simple fix. I think, oh wow, we had a pretty fast runtime. Not great memory footprint, though. Um, huh. Okay. I'm not sure how to feel about this. I mean, we got the right solution. Eventually. I understand how this works. I'll just go through it one more time, right? So it's kind of exactly what we were doing before, right? We loop and increment the right pointer on every iteration, but essentially while our total, which is a total running sum that we're keeping track of, right? So it's the sum of all the values between L and R inclusive. So while that total is greater than the target, so that's when we know we have a hit, right? If the total of that sum is greater than the target. So we found a subarray that meets the criteria, right? We found a subarray that is greater than the target value. Now that we found it, if we haven't found a match yet, we'll set our return value to be that match. Else, only update the return value if our match is better than the previous return value. And then here's the key. So at the end of the loop, is what we do is we increment the left pointer. So that will make our total smaller, but it'll also make our subarray smaller. So by doing that, we're kind of taking off bit by bit from the subarray to see, okay, does this subarray still work, even though we shaved off one value, right? So this is like that whole popping process. And if it isn't, if our subarray then becomes insufficient, well then this while loop terminates, and then we move to the next iteration and we add one more on the right. I should really get like, let me try opening up like Paint and explaining this better, just to make sure I like fully know what's going on here. I don't know if that actually shows. Let me add Paint. Okay, I honestly have no idea if that is working. Is that actually visible? I really don't know. Okay, you know what? I don't know if the paint is visible. I'll figure that out next time. But yeah, let me just go through the example test just as an example, right? So we got 2, 3, 1, 2, 4, 3. So L and R both start on 2. That is not greater than the target, greater than or equal to the target of 7. So we move R to 3. Now our total updates from 2 to 5. It's still not enough, so we increment R again. Now it's 6, still not enough, increment R again. Now it's 8, that is enough, so we set our return to right minus left plus 1, which is 4 in this case. And now we're at the point where, okay, we had a hit. Now let's increment left, because if we increment R, there's no point in incrementing R, right? We know we're going to keep finding hits. And there's no point in doing that, because if we increment R, we're just getting a larger subarray. Like we don't need to check any subarrays of length 4 or 5 anymore, right? We already found one that was length 4. There's no point in doing that. So now we increment left, and then we pop that 2 off our running total, so our total goes from 8 to 6. That's not enough. Now we've gone below the target, so we increment R again. Okay, and now we're at 10. So that is enough, but again, that's also 4, so we don't need to do anything. But now we can update our left pointer. We can pop the 3 off. So now we got a 7, and L is now on that 1. And so that is a hit. So we then update RTN from 4 to a 3. So we're in this while loop right now, basically. We've run it 2 iterations, right? Because we hit the 10 and then we hit the 7. So now we're gonna do this. We're on this step now of popping and incrementing. So we pop L, and you get 6. So L is on that second 2 now. So L and R are basically at this point in the array. That's too little. So the while loop terminates because total is less than target. And then we go back up. Right is incremented by the for loop, and then we increment the total. So R is now on that 3, and then we increment the total to 9. That is a hit. So now we're inside this while loop. This doesn't do anything because our minimum was already 3, but now here's where the total is updated, right? So the total goes from 9 to 7, and then we move L1 to the right, we increment it, and now it's actually still greater than target. So now when I do this, it'll update RTN to 2, right? And then when we pop L again, now L and R are actually on the same element. They're both on that last 3. But no, L will never overpass R. But now that L is on that 3, this while loop finishes running because total is less than target. And now right has reached the end. This for loop does not run anymore, and then we return the last value. So overall, I think I actually solved it pretty well. It's a shame that I didn't read the problem correctly because I think I actually solved it correctly for only matching targets. Like I solved that correct. I mean, that wasn't the correct problem, but I did do that. But I also think I found the correct solution. Once I realized my mistake, I found the correct solution relatively quick. What threw me off here is that, I mean, in these examples, like 4, 3, that's an exact match, right? And then this 4, that's an exact match. So that threw me off because I was like, oh, it's an exact match. So I think I just need to read more carefully now going forward problems. So that was good, I think. Yeah, I'm trying to think. Do I want to do one more problem? So we did that one yesterday. We did that one just now. Let's open up minimum window substring. Let's see if that has anything. Oh, okay, this is a hard problem. I don't think I should do this. I don't want to attempt a hard problem on like day 2. So I'll come back to that eventually. I think I'm like mostly comfortable with sliding windows now. Yeah, this looks pretty hard. Maybe we won't do that one for now. 2 pointers. This is an interesting thing. So when you are given 2 arrays to process, it's common to have one index per array. Honestly, you know what? I think I'll call it a day here. I don't want the video to be too long, but maybe later tonight I'll record another one. But I think this is a good stopping point. So yeah, see ya.